This second lesson is about a quantity called impulse. An impulse is very closely related to momentum. So we're going to start out this lesson by playing around with some formulas and some familiar ones from last year and some from your lesson from yesterday. So the first order of business says, prove that change in momentum equals the mass times change in velocity. Now it's important to remember that change in anything means final minus initial. So if you have change, remember change gets this delta, this triangle sign, change in velocity would be v final minus v initial. If I had change in time, this would be time final minus time initial. So change in is given this delta sign and it means final minus initial. So here we're going to write that out. Final of whatever it is minus initial. The final condition minus the initial condition. So in terms of momentum, we're thinking change in momentum. Remember, momentum is a vector quantity. That would be your final momentum as a vector minus your initial momentum as a vector. So change in momentum equals momentum final minus momentum initial. Now from our previous lesson, we know that the general equation for momentum is mass times velocity. So my final momentum, well, my mass is not going to change. So what must change to give me a final momentum is going to be my velocity. So I'm going to substitute those in. So change in momentum is mass times velocity final. That's my final momentum minus the mass times my initial velocity. Again, mass isn't going to change. We're not dropping mass yet. We may be later on, but mass is going to stay the same. Velocity final minus velocity initial. Now I have a greatest common factor of m in both of these, so I can factor that out. So my change in momentum then is going to be mass times velocity final minus velocity initial. And we set up here, well, final minus initial of anything, that's the change in. So this must be then mass times change in velocity. Velocity final minus velocity initial is mass times, or change in velocity. So that is, so we started with was our change in momentum is going to equal to our mass times our change in velocity. And that is actually the definition of impulse. Impulse is defined as the change in momentum. You can write that out in words if you want to, but that is what impulse is the change in momentum, how much your momentum changes. And that's going to end up being actually fairly important throughout this unit. So example number 1 says, fill in the steps below to find the impulse equation. So this is one of our impulse equations, but there's actually another one, which we're going to find below. We're going to show that this is equal to mass times change in velocity. So it says, take Newton's second law, F net equals ma, and solve for acceleration. So you'll notice they have some quantities in bold. This is a textbook's way of writing out something that is a vector. So anything in bold, read that as having a vector arrow over it. So we want to solve this for acceleration. So we're going to divide both sides by m. This is going to give me F net over m. And a lot of the times we're going to just abbreviate this as F over m. Just avoid writing the net, but remember that this is actually going to be your F net. So F over m is going to be my acceleration. And then we're going to use the kinematics equation, v final minus v equals v initial plus at, and solve that for acceleration. So if I subtract v initial to the other side and divide by t, that's going to get me acceleration. So v final minus v initial divided by t, that should look familiar, v final minus v initial over t. And then it says setting these two equations equal to each other, so we're going to take my f over m and set it equal to v final minus v initial over t. And then cross multiply. So I'm going to multiply the t up with the f and the m up with the v final minus v initial. So this is going to give me f times t is equal to m v final minus v initial. And after I do that, then it's just a matter of going, oh yeah, v final minus v initial, that was delta v, so this is going to give me f times t equals m delta V. Where have I seen that before? Well, that was what we were talking about when we talked about momentum. So this must be then my equation for momentum, my equation for impulse. This is change in momentum. So what this signifies is that a force acting for a time will change the amount of momentum in the system, and this is what we call impulse. So this is actually what we're aiming for when we're talking about an equation for impulse, is a force times time. And now you do need to remember this is my net force. It's not just any force, it's my net force is equal to my impulse, change in momentum. Okay, so here's that summary of that idea. I've got my F times T is equal to M delta V is equal to delta P. And again, remember this is my F net. Just write that in small there just to remind us. So F net is your net force, M is your mass in kilograms, T is the elapsed time in seconds, V initial is the initial velocity, and V final is the final velocity. Now we could also write this out as F net equals M V final minus M V initial. Sometimes that's going to end up being the most convenient way to have things. Just remember that this is where we came from.